Let's just have a quick look at chemical indicators. These are things which give us an idea that something has certain characteristics about it. Now, we tend to use indicators to try to tell us whether something is acidic, but the crazy thing is we have to use the right indicator, otherwise we can fool ourselves. So as I said, chemical indicators tell us if something is present, and it's really funny, they do it by changing colour. So we try to use them to change colour to tell us when something's an acid and something's a base or an alkali. Now, the colour change has to, if that is going to be used, and then the colour change must occur at the change between acids and bases, which you'll find out is pH 7. But if we quickly look at this chart, not many indicators actually change at pH 7, if any at all. The closest one is Bromothymol Blue, which is this fella down here. You can see it's yellow up until 6, then it becomes green up until about 7, and then it becomes blue. So in acids it's either yellow or pale green, and in bases it's blue. So it's the only other one that will actually do this for us. And as I said, it's not an easy thing to do. If we look at something like methyl orange, which is a very common one we use in the lab, now we see that it changes colour at pH between 3 and 4. So anywhere in that, it can change into an orange. It goes from red in low pH, in other words acids, to pH 3 to 4, which is still acid. And then at pH 4 and a bit, it changes to yellow, which is still acid. So we can't really use it to tell us if something is an acid or a base, because all the way through from pH 4 and a bit, right through to 14, we see this is one colour. It doesn't change here where the acid-base line is. So it's really, really hard to say that chemical indicators are very good. There are so many different indicators around, and that presents its own problems. They each change colour, and it's not always, we've learnt that litmus paper is red in acid and blue in base. But that only works for litmus paper. We've also seen Bromothymol Blue is blue for acids and yellow for bases, which is crazy. So the colours, you can't even rely upon an indicator to be one colour in an acid and one colour in a base. So they're not very good in lots of different ways. But they do have their uses. They do tell us a little bit about what's going on. And if you take on work a bit later on in sort of senior chemistry, you might learn they become very useful in a thing called a titration, but more about that later. And the most amazing thing is, it's not at an exact point. In other words, they won't change at pH 3, they change somewhere between 3 and 4 maybe. In the case of methyl orange, they change between 3 and 4. So it really doesn't be that exact, is it? So it's not really accurate whenever we do anything with indicators. They tend to be a little bit wishy-washy, in other words, telling us exactly when things are happening. It's sort of like saying about 3 or about 4, this is going to change colour. And it's not an exact thing, so that's why we should always say that indicators are useful but not accurate.